So in today's class, we'll try to see what other kind of heuristics, biases which arise from heuristics, and we shall try to see first one example that is here. Okay. Before that, we like to have some preliminary discussion. It's like that the biases which we'll try to focus today, those are representativeness, availability, and anchoring. So we'll try to learn these things in today's class, which will be our special focus today. So the thing is that Amos Taversky and Daniel Kahneman, we heard about these people in an earlier paper we read in one class. So the thing is that what they concluded, that people though need the probability in taking many decisions, but people have lacking of knowledge in estimating the probability. So people somehow underestimate or overestimate the probability that compared to what should be the actual. So in many financial decisions and in also our personal decisions, day-to-day decisions, we need to take help from probability. So one example can be that in first quarter of 2021, what will be the increase in the quarterly EPS of a particular company in which you are interested. So the probability associated with certain amount of EPS vary from person to person. So analysts estimate different probabilities, different EPS, but we try to see that how this probability estimation get manipulated because of having some biases in our mind. So before going to have those discussion, we like to have some experiment. So one experiment is you are watching my screen. You see description of a person has been given here. That Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issue of discrimination and social justice, and also participated in anti-nuclear demonstrations. So the experiment is like that you have to estimate probability by yourself based on this statement. Based on this statement, you like to assess the probability of each of this event. Each of these events are mutually exclusive. I mean, you have to estimate the probability for each of this event independently. So I'm not telling you to estimate the probability in terms of percentage. Rather, I want to tell you to rank those in a way that where 1 indicates the most probable, most likely, and 8 indicates the least likely. So you can say that if the rank is 7, it is close to less likely, or if you place a rank 2 to some event, it is close to more likely. Okay, so I'm giving you 1 minute time. By this time, what you will do, you will try to give ranking of each of this event based on the description above. So I hope you can also write on my screen using your Zoom annotation. Using your Zoom annotation, you can also write on my screen. Or you can write in your script also, on your script. Have you got the experiment, how you have to proceed.
Sir, but any of these that we choose, it will be kind of judgmental.
Yeah, judgmental based on this description, what you feel. There is no right or wrong answer. We just want to evaluate your probability estimation skill, how good you are in estimating the probability. There is no right or wrong answer. We just want to check that how knowledgeable you are in basic rules of probability. Okay, it's 4:16, so we can proceed. So I hope you all have ranked these events by yourself, and we like to show you that what have been found in earlier experiment on an average. On an average, it has been found that people rank these events in this way. So which event people have found more likely? Can anyone confirm?
She is an active in the feminist movement.
Okay, fine. And which event have been found very least likely?
Linda is an insurance salesperson.
Okay, fine. Now you see that number 8, there is an event, right? Linda is a bank teller and is active in the feminist movement.
Yes.
Okay. You see this event is a conjunction or intersection of these events and this event.
Yes. Yes, sir.
Okay. So we can say these two events, which I just have darkened using the red color. These two events are independent event. These two events are independent event, right? Okay. But you see, this event is a joint event.
Yes.
This event is a joint event. So you see, this event probability is higher than the probability of this event.
Yes.
It is less likely, it is more likely, and it is also more likely. But you see, relative to compared to 7 and 8, you see which one is more likely, the conjunction event or the independent event? Sorry, not this one.
The
this
joint
one.
event or the independent one?
Okay. I should not box
The
this.
bank teller, yes.
This one. Yeah, this one is right. Okay. You see, compared to this one is more likely or less likely?
More likely.
More likely. Okay. Now, are you familiar with the Venn diagram?
Yes, sir.
Okay. We can use this probability. You can also use the Venn diagram to learn about the probability. Okay. we can say that this is the probability for the feminist movement, and this is the probability for bank teller, and this one is the
Is
probability for both, that the Linda is a feminist activist and also she is a bank teller. So can this joint event probability, this one, let me highlight this in this way, this one, this area, can it be greater than this one or this one? Can this joint event probability be greater than the probability of this independent event?
No, sir.
No, sir.
No,
Anyway,
No, sir.
okay, but what people did? People estimated the probability of joint event more compared to the probability for the independent event, this one.
yes, in the case of bank teller, yes, but in the case of feminist movement, it's lower.
Yeah, I'm not looking at here, I'm just looking at here. But what people did? People estimated the joint probability intersection in a way which is greater than the probability of the independent event. Can it happen? Can it happen? Yes, no? Because it already shares the characteristics of this and also characteristics of this. In any way, it cannot be greater than the probability of the individual independent event which have been intersected here.
But sir,
And
what if more emphasis is on the feminist movement, and that's why the probability has become so much greater in this joint case?
sorry,
Sir, what if the lower probability is, sorry, the higher probability is because of the feminist movement? Maybe the bank teller probability is higher, but sorry, not higher, lower. I'm just mixing up the numbers.
okay.
But the feminist, because of the feminist movement, the number came down
In
so
terms
much
of feminist movement, the number is okay.
lower. Yes.
It is less than this one. Okay, but in terms of bank teller, this number is greater than this number is greater than this. The probability for this is greater than this. The problem is here with this. The problem is not with this. Okay, but either whatever, the problem has happened here, right? The
Yes.
problem has been created by people when they estimate the probability for the joint event. Okay, so probability, in terms of probability, this number, the probability number for this event should be less than this event probability, the bank teller's probability, at least. Okay, but people overestimated the probability of this joint event. Okay, so has anyone done this kind of estimation, that you have given more probability to this joint event relative to the probability you have given for this event and this event? Has anyone done this kind of estimation? Anyone? You are very rational. That's why you are smart in estimating the probability, and you have you are very much aware of the probability rule. Anyone? Okay, this is very good that you are very aware of the probability rule, that you have not done such mistakes. But Taversky and Kahneman in 1983 found that 80 to 90% people estimate this one is more probable compared to this one in their 1983 paper. Okay. So the thing is that the people are overestimating the probability of joint event relative to the probability of the event which are creating the joint event. This kind of problem is known as conjunction fallacy. So we'll talk about it more, that people have lack of knowledge in making difference between the probability of independent event and the probability of joint event. So sometimes, let me give you another case that, say, there is a probability of winning a lottery and the probability that a person will be happy in the next day. So it has been found that people estimated the probability, joint probability, that a person has won a lottery and is also happy in next day, greater than the probability of the person is happy in the next day. So they have violated the probability conjunction rule. So opposite thing might be true, that after getting the lottery, the person becomes the person has come to know, or the person has come to know some sad news which would require a high amount of money from him or her, and that is only available from the lottery he just has won on yesterday. So this kind of mistake people do in making the probability estimation. So keep it in your mind. We'll try to explore what is the reason. Someone has already given some hint that how this number has become a greater number. There, she tried to link up something. We'll try to take note on that after a few moments. Okay. Let me give you another problem: base rate neglect. For example, people have been allocated into two groups, and one group, say group A, another group, say B. And these people who are in group A, they have been told that I have picked a description of a person from a group of people in which there are 70 engineers and 30 lawyers. This group of these people have been said that I have taken a description of a person, and this description has been taken from a population in which there are 70 engineers and 30 lawyers. And this person, these people who are in group A, a question has been given to them that I am giving you the description which I mentioned about, which I have collected this description, and tell me what is the probability that the person about which I have given you the description is an engineer. Keep it in your mind. Then again, another group of people are here, and this group of people have been said that I have taken a description of a person, and this description has been taken from a population in which there are 30 lawyers and 70 engineers. They have been said this distribution. Then this description has been presented before these people who are in group B. And the question has been given to them that now, what do you think? What is the probability that the Steve is an engineer? So after giving this description of the distribution, a statement has been given to them that Steve is very shy and withdrawn, invariably helpful, but with little interest in people. A meek and tidy soul, he has a need for a structure and a passion for detail. What do you think? What should be the response? Just give me some estimate. What should be the response from people in group A, and what should be the response from people in group B? What do you think? Okay, let me simplify the answer response. Which group is likely to give higher probability that Steve is an engineer? Steve is an engineer.
Group A.
Group A. Okay. Anyone has different opinion? Okay. Can anyone expect that the inverse is true? That group B will say that they will give higher probability that Steve is an engineer relative to group A? Okay. Out of surprise, both group have mentioned that it is 50%. Both groups have given the same number. Do you think is it reasonable that both group will give the same number of probability? But actually they did.
But sir, it makes no sense. A group of higher number of engineers should know if the person is an engineer based on
Yeah.
their characteristics.
Right. But it has been found that this group and this group have given the same number for the probability that Steve is an engineer. And it is not my claim, it has been found in experiment. Okay, probably you are in behavioral finance class and you have been given thought to think rationally. That's why your approach is to think every statement very carefully, because you know that something is different relative to what I am seeing on the screen. That something will be said later in this class and that will be different from my response. That's why you are very careful. But when people are not very careful, it has been found that people are in a normal stage, or people are in people are not in a controlled environment. People conclude the same percentage for the probability that Steve is an engineer. Okay. So you have mentioned that it is reasonable to estimate that same number. Obviously, it is irreasonable, but it has been found. So the thing is that what people didn't do, you just have mentioned already. As these people has been given a description earlier that I have picked this description from a distribution of people in which there are 70% engineer and 30% lawyers. That's why, what is the prior probability before having this statement? Let's say this statement is not available with you. What people in group A will conclude? 70%? That Steve is an engineer? Yes, no?
Yes, sir.
Okay. This one is the prior probability. Prior. Okay. And how people in group B will start? They will start by saying that it is 30%. It is their prior. Okay. Now, when they have seen this kind of description, what do you think in general? This description look like a description for an engineer or for a lawyer? What is your kind of general perception from this statement?
Engineers.
Engineer. Okay. In that case, this number should be adjusted upward. This number should be adjusted upward for having this new information. And this number also need to be adjusted for having a new information. And as the base rate is already higher, it is likely that this rate will be very high relative to this number. So what people didn't do, why people have ended up saying 50% here or 50% here. I'm just giving you a 50% number. The number is not necessarily 50%. The answer was that they provided the same number. So it is unlikely. So what is the reason that they have come up with the same number? What is the likely reason? The likely reason is that they didn't look at the prior probability. They didn't look at the prior probability. So the prior probability should be adjusted upward or downward after having the new information and looking at the new information. Can you recall the base formula I showed you earlier? That if the probability of event A given the new information has arrived, how can we estimate this number? What is the probability of event A given that new information has arrived? We should have the probability of information given the event A and unconditional probability of the information. It should be multiplied by prior probability, which is before having the new information. This one, prior. It is the prior. And what is it? It is the posterior. You should have learned it from your statistics class. Okay. So in this way, people should give appropriate weight to the existing information and the new information. Okay. So can anyone tell me that we are repeatedly mentioning that base, if you want to be a rational, always use the base formula to estimate to update your belief. Rational people always use the base formula to update their belief. Can anyone just give your idea that what is the reason why we are saying that rational people always use the base concept of estimating probability to update their belief? Yes, no? Let me show you the reason that the base formula can be written in an alternative way. In this way, say this is the probability of event A. Let me give you some indicative. Say probability that earnings will earnings will rise. And you want to update this probability that earnings will increase because you have received a new signal. So you already have the estimation that what will be the probability that earnings will go up, and you are not sure that what is the probability that the signal is good, the signal what you have received that earnings will go up. You are not pretty sure that, but you are wanting to estimate a probability. So the thing is that how can we adjust this? How can we give weight to this and weight to this? This is the prior and this is the new signal. So one way is to use the variance, inverse of variance, to place weight for this and weight for this. So say it is in this way, 1 by sigma square for this one that earnings will go up, and 1 by sigma square that earnings will go up for this event, the variance, and 1 by sigma square for this signal. And you have to put a plus sign here. And again, you are writing inverse of variance, but for what now? This is for the variance for signal. And here the same, the variance of the earnings will go up, inverse of the variance, not the variance actually, 1 by variance of the signal. So this is how the Bayes theorem can also be written in alternative way. So the thing is that you see that if the signal is more appropriate, the variance will go down or go up. If the signal is more reliable, more credible, the signal what you have received, if it don't try to hang up by looking at this big formula, just try to concentrate what I am asking you, that if the signal is more credible, more reliable, the variance will be greater or variance will be smaller.
variance greater হওয়ার কথা স্যার।
If the signal is more credible, signal is more appropriate, more reliable,
No, sir, it will be smaller.
it will be smaller. In that case, you should put more weight to this or to this. You should put more weight to this, to the signal, relative to what the probability you already have estimated. You should place more weight. So this mechanism actually places more weight in this way. When the signal is more appropriate, this number goes up. And when this number goes up, at the same time, this number goes down because signal is more appropriate. So rational thinking is that when you have more information and that is more credible, go for placing more weight to that information. And if the information is less credible, in that case, place less weight to that information in incorporating that information in your decision. So that is the way how rational people should make decision. And that's why we just try to argue that when people make decision in the Bayesian way, those people are the rational people, or those people estimate their belief in a rational way. So we already have learned that people have a tendency to ignore the prior probability or the base state when making their probability choice. Okay, so it reflects that people place more weight on the description. People place more weight on the available evidence compared to the weight people give to the size of the sample. Can you recall that 70%, 30%? Already 70% is engineer. That's why more weight should be given to this event. Less weight should be given to the description. But what people do, people place more weight, which is kind of description, and people place less weight on the prior thing, and which is kind of also sample or weight. There is a paper, interesting paper, that has found that people have a tendency to look at the strength of the anything and give more weight to the strength and less weight to the content. And let me give you a realistic example with you so that it will be understandable to you. For example, that example is given in the paper that you are likely to take a recommendation letter from your faculties. Okay. So, which is more important? The person from whom you are taking the recommendation, or the contents what have been explained in the recommendation letter? Which thing is more important according to you? Or which thing should be placed more weight? Yes, no? Have you got the question? I mean, the person who has written this recommendation letter, that should be given more weight, or the things what have been written in the recommendation letter should be given more weight?
Both should be equal, right?
Sorry?
Both
Both
should be
should be
equal. sir.
equal. Okay, that is the safe answer. Okay, there are arguments. Some universities place more weight on the person who has written this. Some universities place on more weight on this, what has been written here. But the general thing is that what have been written in this recommendation letter should be given more importance. To know about this person, what is your purpose? Your purpose is to know about this person on from of for whom this recommendation letter has been written. So just by looking at the person who has given this may not give you sufficient information about the quality of that person. But if the contents are adequately explaining the characteristics of the person, in that case, it will be easier to evaluate the person. Obviously, there should be a debate on what I just have mentioned. So the strength is the person who has written this recommendation letter, and weight is what have been included in this recommendation letter. Have you got it? People tend to focus more on who has written this relative to what have been here. If I just like to relate a relative example, there is some advertisement which may misguide people because those advertisements use some iconic person in their advertisement. That's why people tend to place more weight on that person, and people tend to forget what is the actual content in the advertisement, and on the actual value of the product, what has been presented by that iconic person. Have you fallen in this kind of trap, that some iconic person is promoting something which is not very good, but as that person is iconic and you tend to believe that that person will always give you the right information, that's why you tend to believe that that product is also good, but actually the product is not actually good. So that person is a kind of a strength, and the actual value of the product is the weight. Have you got this? Have you got it? Yes, no? I'll try to share a paper, interesting
Yes,
paper on which I am giving the reference. That will be very interesting to you also. Okay, gambler's fallacy versus hot hand. Remember, we'll try to come up with a conclusion after having this kind of discussion on this kind of what should I say, this kind of conflicts what we have been discussing for last couple of slides. Okay, so say you are playing a poker, or you are all are playing in a gamble. You are all are playing in a gamble, and you see a person say that person is name is P. That person name is P. This person P has been winning in the game or the gamble or the poker game for several times continuously, and you believe that, and a belief has been built in your mind that he has a hot hand. That's why he has been winning. And immediately among you, two group of people will be created. Two groups, one group A, another group B. This group will start believing that this person has hot hand, and say for example already 4 attempts have been already taken, and this is the 5th attempt, and this group of people tend to believe that this person P will also win in the 5th attempt. There is another group in B who are in B, they start believing that as the person P already has won several attempts, 4 attempts, and in this 5th attempt, this person will surely lose. Does it seem convincing that this kind of group this kind of groups arise when the gamble, poker, or this kind of games are happening, are played?
I think people believe so, sir.
People act in this way?
Act in this way, right?
Okay. Say for example, Bangladesh national cricket team have been losing the toss for last couple of games, for couple of matches, last couple of matches. One group of people tend to believe that in this match of today, Bangladesh national cricket team captain will surely lose the toss. This is one group. And another group tend to believe that as the Bangladesh lost the toss in last several matches, in this match, surely the captain is going to win the toss. Okay, what do you think? This group is placing a heavy weight that it is going to be a win case. Sorry, yeah, it is going to be a lose case, that Bangladesh will lose again today. And these people are also putting more weight that the Bangladesh will won the toss today. Why I am saying more weight? Why I am saying more weight? Just think of
Because
Poker
it has
game.
been happening for
poker
couple of
game,
matches.
gamble, toss, all of these events are random event. All of these events are random event. If you look at the large number, always there is a 50-50 chance that you will win the toss or lose the toss. If you take the story of 10,000 matches, what will happen? You will end up that Bangladesh has won 50% toss and lost 50% toss. This kind of statistics, or you will see that Bangladesh has won only 10% or and lost 90%, which is more likely. What is expected, this one or this one? Remember, tossing coin is a random event, and obviously there are two possibilities, head or tail. Is it convincing? What should be the expected probability? 50%, 50%. That the
Close
person,
to that, close to 50-50, sir. Close
yeah,
to
the
50.
person will won the poker game in the 5th attempt. It is 50-50. I'm not saying 50-50. I'm just saying 50-50, just for estimation. But remember, it is a random event. So but just by looking at this 4, or just by looking at the 4 or 5 previous matches, you cannot say something, or you cannot guarantee that the person is going to win or the person is going to lose today. Can you say like this?
No, sir.
But what people do, people obviously go into these two groups, or there are another group who is group C, which is more likely.
The group A is more likely. Actually, they predict based on previous.
Okay, but the thing is
history,
that these two groups always create, right? These two groups, and they do the mistake in estimating the probability, or they are right in estimation, in their estimation. What do you think? What do you think? This kind of problem is known as gambler's fallacy. Okay, because the chance of winning and the chance of losing in the current event is equally likely, but just looking at the limited evidence, you cannot think of what is going to happen in the large population, large number of events. But what people tend to believe that the population will look like a sample. Population will look like a sample. Can it happen? Population will look like a sample. Population may differ significantly from sample if the sample is not appropriately taken. Okay, so this kind of problem is known as gambler's fallacy. People end up estimating higher probability for something, assuming that the sample reflects the population, but actually it is not true if people are aware of the true distribution. Okay, the same thing happened when we played dice. How many sides are there in dice? How many sides in dice?
6.
6. So each of these side is equally likely. If it is 1, it is 6, it is equally likely. But when you continuously end up getting 1, 1, 1, the dice game, your game mates tend to believe that, one group tend to believe that your next attempt will be 1. Another group tend to believe that your next attempt will be 6. Does it happen? So each group overestimate the probability. Okay, next one is the overestimating predictability. So in general, when people are asked to predict something or to take something, to predict something, people end up giving higher percentage for the reliability or for the predictive power of that variable. For example, you tend to believe that, or people have a belief that a person who was very good in the high school, or okay, it will be very good to look at the SSC GPA. People tend to believe that if a person has a very high GPA in SSC, that person undergrad CGPA will be very high. And people tend to believe that there is a strong correlation between this. And they tend to believe that this correlation is significantly high. Okay. But what do you think? Does it happen? You'll end up getting a good number of students who are not good in their SSC, but they did very well in their undergrad. And the opposite is true. And what is the reason? There is a natural thing which is known as regression to mean. Have you seen this kind of graph in any index or any price, or you always look at this kind of graph? Which one is more prevalent? This one, A, or this one, B? In looking at the performance of a person, which is more likely to look, if this kind of graph is more likely, or this kind of trend is more likely?
Sir, B is more likely.
Is more likely. So it is said that there is a mean. There is a mean. The mean is here. This is mean level or average level. So if people is performing at a very high level, say for example, you are spending 20 hours for a study at this level, and you are ending up getting the highest score in your exam. Do you think it is very sustainable, or you will get broken?
স্যার আপনার কথাটা দূরে চলে গেছে স্যার, সরি।
Okay, what I'm asking, that a person is staying here, that person is spending 20 hours in his study daily, and that person is staying here. Do you think in later of his life it is possible for him to continue 20 hours of study, or it will calm down?
It will come down.
It will calm down. It is not a sustainable level. Okay. Now think of a person who didn't study in his life. Say he used to study for 30 minutes daily, or not a single moment in his life, or some days. But to continue his graduation in an university, he should raise this level to some considerable extent, say 4-5 hours, for having a good score to end up his graduation with a good GPA. So that's why it has been found that it is not always true that the high grade achievers in the SSC or HSC will also be good in their result in the university. But people tend to believe that if a person is good in their early school, he was first in his class from class 1 to 10, you will see a considerable number of people who are first in their class from class 1 to class 10. They are now struggling to have a good 3 GPA in undergraduate class. But they had the first position in their local school. Have you seen this kind of things? So if I just look at the high school position and overestimate and estimate the predictability that the person will also do very well in the university education, that is not very likely. So people end up estimating a higher probability always. And people, when people are given the task of predicting something, people tend to believe that they have a high predictive power. So the thing is that what is the reason why people do this? Let's start with conjunction fallacy, base state neglect, gambler's fallacy, overestimating predictability. So Taversky and Kahneman tried to give some answer. The answer is that people tend to have this kind of representativeness bias. As the word is a big word, that's why we are giving the R to denote it. So the thing is that if say you have the event A, now the event B has come, but you are not very sure that how even what is the probability of event B, but you tend to recognize that to some extent event B look like event A. In that case, you tend to place more probability to event B if B looks like A. If the opposite thing happens, that if B does not look like event A, you tend to give lower probability for event B. So what do people look for? People look for similarity. So similarity and the probability are the same or different? Yes, no? These are different. In probability, you have to abide by the conjunction rule. In similarity, you do not have to abide by the conjunction rule. So when Linda is a bank teller, and Linda was also feminist, what happened here? People place more probability to this. People tend to believe that as this number is already high, you see that Linda is active in the feminist movement. And when people try to relate it, relate the new event with the existing event, people give more weight, people give more probability to it. So when these have been combined, that active in feminist movement, already people believe that it is high. But when bank teller say this information was given, so this information was given, and when this information is given, people tend to believe that this event is similar to the existing belief of the people, and that's why people end up placing more weight. And another example, when I gave that winning a lottery and the person is happy, people tend to believe that the person who are winner in the lottery, they tend to be happier person. But the reality may not look like that. The people who won the lottery may not be the happier person in the next day. The situation may go in different direction. So that is one reason Taversky and Kahneman argued that when people tend to believe that an event is representative of another prior event, people tend to give more probability to that new event when they see that A resembles B. And the opposite is true, and people do different then. And what are the implications for the representativeness bias? One thing is that people neglect the base rate. We already have seen it. And also, people do not look at the sample size. Recall that 70%, 30%. People do not tend to look at this. And people have a tendency for the representativeness, people overestimate the joint probability. And we also have given in Gambler's fallacy, which has been summarized here in a small number fallacy. It is an implication of the representativeness bias. So you are probably aware of the law of large number from your probability. Law of large numbers. Have you heard about it? Law of large number. So summary is that the true probability will be reached when you attempt for large number. For example, say a person is getting 1, 1, 1, 1 in his dice game for last 4 attempts. So you end up saying that it is 80% that this person will get 1 again in his 5th attempt. But if you look at 10,000 attempt, or say 1 million attempt in the dice game of that person, it is likely to see that the probability of getting 1 is how much? 1/6. It is the law of large number. But when people just look at the sample of limited number of events and end up giving higher probability, in that case, people have a small number fallacy, and that is also known as law of small numbers. And people have a tendency to forget the regression to the mean. So a company, for example, is doing very good, and you end up saying it is very high likely that that company will also have a high earnings surprise in the next year. That thing may not have appear true because of the regression to the mean. If a company is doing very good, for example, right now the wireless telecommunication companies are giving higher giving their disclosure with higher EPS, because they have been end up raising their revenue for lockdown and reducing their cost by not setting up new base station, new network devices. For two reasons, they are getting higher EPS, higher earnings. But do you think it will be continue for longer years, that people will stay at their home in long time, and company will continue to not investing in their new infrastructure for long years? Can the company continue like this?
No.
So that's why you have to understand the regression to the mean. Okay. So for the representativeness bias, what happened, people tend to overreact to new information. And because of the representativeness bias, when people see that probability that B is sufficiently representative of A, B is sufficiently representative of A. A is a new information and B is existing. So what people will do, people overestimate when it is representative. People overestimate the probability because of the representativeness bias, which is greater than the probability if you would estimate using the Bayes theorem. So that is the implication of the representativeness bias. And the thing is that for this representativeness bias, whenever the new information arrives and people may not think the new information in new way, people tend to categorize those information in the existing information or what they already have. So that's why people end up estimating higher probability when they see that new information is representative of existing event or existing variable. So there is an example from the CFA reading. You will try to answer this by yourself, and we just try to conclude the representativeness bias just by saying that what are the consequences of having the representativeness bias. You already have discussed it, that people adopt a view or a forecast based almost exclusively on new information or a small sample. People tend to place higher weight to the information which has been available from the small sample. But this kind of why people do this kind of thing, because it is not easier always to process the new information. We like to place ourselves in a comfort zone. So if we try to categorize the new information with the existing thing, in that case, it is easier to process the information. Otherwise, it will be difficult to process. So we always, what are the guidance to correct this kind of representativeness bias? We have to be aware if we do any kind of mistake, which may be a statistical mistake, and we have to weight the information, new information with appropriate weight. And also we have to follow a disciplined investment strategy to increase the long-term return of our portfolio. And another bias which is closely related to the representativeness bias, that is the availability bias. The thing is that when some events which are very easy to recall, those events people tend to believe that are more likely compared to the events which are not easy to recall in our mind. So you can recognize that which things are easy to recognize in our mind from the learning what we learned when we learned about the perception, how perception works, how our memory works. We talked about it in our previous class. So which things comes in our mind very easily, we tend to believe that those events are more likely. So if I just ask you this question, which is more likely? The number of words starts with K is more likely, or the number of words in which K is in third position, that number of words is more likely? Which words are in a greater number, this one or this one? Yes, no? I'm giving you 30
The
seconds to
first
think
one,
of.
sir. The first one, the beginning with K.
Beginning with a K. Okay, any other response? Any other?
Begin with K.
Begin with a K. Okay. Okay, the answer is that because it is easy to think of that the word begins with K. And it is not easy to think that K is in third position of a word in a word. As it is easy to think of, that's why people tend to believe that the number of words in which it begins with K should be greater than the number of words in which K is in a third position. Have you got the answer why you have picked the answer? Because it is easy to think in your mind. It is not easy to think in your mind that the word starts K in a third position. Okay, and it has been found true in several experiments. So let's try to discuss another experiment that is interesting, which has been mentioned, that egocentric judgment. Egocentric judgment in which people tend to overweight their interest and underweight others' interest. So one survey was made among the married couple. So married couples were asked that out of the household chores, how much percentage you complete and how much percentage your spouse complete. So interestingly, it has been found that husbands are saying that 60% of household chores are done by me, and wives are saying that 60% of household chores are done by me. What is the summation?
120. But
Can it be?
be 120.
Can it be?
No, sir.
No.
What's the reason?
Biasness, sir.
The reason is that it is not
They're
a kind
always
of gender.
putting more weight in their probability.
Okay, the thing is that the words which have
Most
been done by
probability is
husband,
100%.
those are more likely to be recalled by husband. And the words which are done by wives, those words are more likely to be recalled by the wives. So in a second experiment, husband have been asked that can you recall that when your spouse went to super shop yesterday? The husband couldn't recall, and the same thing happened in case of wife. What is the reason? People tend to remember their own behavior better. What's the reason? It is easier to recall. which is not easier to recall what my spouse has done, right? That's why it is the availability bias people tend to exhibit. And we like to explore what are the reasons why people do exhibit this kind of availability bias. The thing is that when some events happened recently, those events are very green in our mind. That's why we tend to end up exhibiting availability bias. Can you recall the primacy and the recency effect we discussed in earlier class? When we see something first, that is tend to be remembered. In that case, it is primacy. And the recency is if it is observed in a very recent days, it is likely to be remembered. Say, for example, we are right now observing that the COVID-19 cases is death cases is ranging between 90 to 110. But we forgot that just 1 month ago, the ranges was in between 20 to 30. We tend to get more, we tend to have a belief that the number of deaths due to COVID is very likely just by looking at this. But if we consider this and we make average, in that case, what will happen? The number should come down and it should be less likely. So that happened for the recency bias. And another thing which contributes to the availability bias, that is the salience. Salience is a thing when something is expressed in a very noticeable way. That event is to be remembered by people very well. Say, for example, can you recall that US Bangla plane crashed in Nepal a couple of years ago?
Yes, sir.
Can you recall that event?
Yes, sir.
Okay. Can you recall an event that happened in the Dhaka-Chittagong highway, the road accident which claimed death of 15 people?
Not like that.
You cannot recall. You cannot recall the accident, road accident, which happened in the last month in the Dhaka-Chittagong highway, which claimed more than 15 people. I'm just asking about a random event. Okay. You see that US Bangla Airlines plane crash, it is very clear in your memory. What is the reason? It was publicized in newspaper continuously, repeatedly.
Yes, sir.
So that thing happens. The availability bias. Okay. So the thing is that what is the consequence when people look at the advertisement of some mutual fund or some asset management company? People end up investing in that company. People do not look at pros and cons of investing in that company in a very detailed way. People tend to believe that as I have been seeing the promotion, I have been seeing the news views on this company, that's why it is very good to invest with this company. But it would be very good to know all the things, to look at the due diligence of that particular company before making investment. So the investment companies are very likely to attract the attention of the people by making their information, by making their products available in the media. So that's how availability bias of the people is exploited by the companies. And if people are suffered by availability bias, people may end up having poor diversification. So that's why it is always advisable to have the appropriate strategy in making their investment, and always to recognize that, am I making investment because I have come to learn about it in a media, or because it happened in recent days, or I have come to learn it from my families? That's the reason why I'm making the investment, or the reason is that this company is really good, that's why I'm making investment to this company. Next one is the anchoring bias. Remember, all the bias which are studied right now, those are related to heuristics, and people exhibit the heuristics by exhibiting these biases, and these are kind of doing some shortcut techniques of making decisions. Remember, representativeness, people make do not use the probability estimation in a right way, because people use the people make the decision in the shortcut way. So okay, anchoring bias. So anchoring bias is the thing that the event which, or the variable which comes to in your mind in a very first sight, that event dominates you, or that number, that initial value dominates you. For example, if you look at this series, can you tell me what is the likely estimate of this answer? Will it be 500 plus number, or 1000 plus number, or 20,000? Don't go for using calculator, or it will be kind of 30,000 plus, or it will be 40,000 plus number. Just by looking at this series, just look at here and pick anyone. Very quick, we have 10 minutes of time remaining.
1000 plus.
1000 plus. Okay, that is very good. Okay, another response, very quick.
Sir,
Okay.
40,000 plus.
Okay, you have used it calculator for sure.
Yes, sir.
Okay, I have restricted the use of calculator. Okay, so it has been found in experiment that the average response from the people, that the number is 500 plus or 512 something, because people look at these initial numbers, 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5, in this way, and people end up saying this number is close to 500 plus. And some people, and the median number, that means 50% people has said that number is less than 2000, and 50% have said that number is above 2000, but the actual number is 40,000. What thing happened here? Because people look at some small values here initially, that's why people end up estimating that this number will be a very small number. But if the number is written in this way, 876 54 3 2 1, in this way, people would not end up that low estimation. Okay, so that is where how anchoring bias affects us. And another thing we like to example is that sometimes for anchoring bias, people end up having some irrelevant numbers. Say for example, in one experiment, that there was a wheel in which 100 percentages were written, 1%, 2%, 3%, 5%, in this way, from 1 to 100. It has been written here. And subject were asked that let's spin this wheel, and a percentage will come here, say 20%, and you have to answer that how much percentage, by the percentage that the number of percentage of countries from African in the UN is higher than this number or lower than this number. I mean, you have to compare this number with the percentage of African countries in the United Nations and percentage of the countries, African countries who are in the United Nations. You have to see, you have to think of that this number, the actual number, we don't know. This actual number is greater than the number which you have got by spinning the wheel. This number, how much is this number? This number is higher or this number is lower? But instead of answering this question, people end up looking for the answer. What is the percentage of the African countries who are the member of United Nations? What are the percentage of African countries who are the members of United Nations? But that was not the question. The question is that how much better that percentage from this percentage, or how much lesser that percentage is from this percentage. So instead of looking at this answer, people end up saying that the percentage of the African countries in the United Nations is this percentage or this percentage. But this question was not asked from the people. And in financial market participants end up exhibiting anchoring bias in a way that you have purchased, for example, GP stock at 330, and you tend to believe that GP price will be 340, 350 by your estimation. You, by your independent analysis, if for some reason, if GP price comes to 50, or for example, say 25, or say 500, or say 600, you don't want to believe on this number. You tend to give an estimate, say 350, 360, which should not be very distant from the price at which you initially bought the stock. Okay, that is how financial market participants exhibit anchoring bias, and that should not be. And we will conclude our class just by saying that what are the reasons for the anchoring bias. So there are two broad views for what reason people exhibit anchoring bias. One reason is that there is a great deal of uncertainty about the true value. Say, for example, if I ask you that what should be the fair value of the GP right now, it is not an easy answer to tell. You have to spend a lot amount of time, effort, and money to know this number. So people end up saying that a number which is close to, say, current market price, or which is close to the 52 weeks price, is a kind of people take a anchor initial value, and people end up saying something which is closer to this, because there's a great deal of uncertainty. That's why people do not try to sink in the sea of uncertainty. And another class of explanation is that people are lazy. People do not like to spend, or people do not like to use their cognitive capacities, their spend their effort to estimate something in a very proper way. That's why people end up saying something which is closer to some anchor. Say, for example, if I ask you that what shall be the GDP growth rate of Bangladesh in the next 2023 to 2024, what will be your answer?
Generalized number 7-8%.
Huh?
Generalized number 7-8%.
7-8%. What is the reason why you are not thinking 12%? Why you cannot think of 4%?
Trend, I think, sir.
That is how anchoring bias affects us, because your mind has been influenced by the thing that, because when you have sat down for estimating the GDP growth rate of Bangladesh, you think that in recent years GDP growth rate was 7%. So let's say something which is closer to 7%, instead of digging into the uncertainty of 12% and 4%. But it may be true. It might be true. But people do not feel comfortable to use this because of the cognitive dissonance associated with these different decisions. So in financial market, participants may stick too closely to their original estimate when the new information is learned. Say, for example, the GP has recently disclosed their 2020 quarter 4 earnings, and they have their EPS for some reason
17% drop, sir.
went down to some extent, right?
17%, sir. Yes.
Yes, compared to the previous
year,
Yeah.
Q1.
Okay, but it is very unlikely that it was estimated rightly by the analyst in our country. Okay,
Sir.
but in that case, already new information has arrived that EPS has gone down, but the financial market participants are very unlikely to to adjust their number by having this new information, because they are believing that the EPS should be a certain number, for example this number. That's why I cannot change this, or it is not easy for me to change this. Okay, if I go for changing this, I have to change lots of number in my Excel sheet. Okay, that's why people do not go for spending this amount of effort for this thing. Okay, so that is all about for today. We'll talk about overconfidence in next class. We tend to like to end up our recording here.